In this video, we're going to look at some examples of writing electron configurations. The easiest way to determine the electron configuration for an atom is to use the periodic table because it tells us what the ordering of the orbitals will be. So we want to remember that the first two columns make up the S block. The 6 columns over here make up the P block. The transition metals, the 10 columns, make up the D block. And to save space, I'm not showing the lanthanides and actinides, but those 14 columns represent the F block. And so what we mean by these blocks is the atomic number actually tells us that the first electron will be placed in an s orbital. And the rows correspond to the principal quantum number. So the first electron goes into the it's the first row, s orbital. Now helium, for the purpose of electron configurations, would make more sense if it was over here. So I'm going to put helium over here. And we'll forget about his actual position in the periodic table. So the second electron goes in also to the 1s orbital. The next electron, number 3, would go into, because now I'm in the second row, it goes into the 2s. The fourth electron also goes into the 2s. The next orbitals that we encounter, going up numerically, this is still in the second row, so it's the 2p's. Then next comes the 3s. Then the 3p's. Then the 4s. Now we're into the d's. The only thing I have to be careful of with the d's is that the d orbital is going to be one less than the row that we're in. So we're in the 1, 2, 3, 4th row. And so the d's are going to be one less, so these are the 3d's. Then back up to the 4p's, the 5s's. These will now be the 4d's, the 5p's, and so on. So when we have oxygen, all I need to do is look and see where is it on the periodic table. So oxygen is right here. And so I just fill up the orbitals until I get to oxygen. So the first 2 electrons will go into the 1s. So I have 1s2. The next orbitals that I come to are the 2s. And they're going to be full because I haven't reached oxygen yet. So I now have 2s2. Now I get to the part of the periodic table where oxygen resides, and so I'm in the 2p's, and there are 1, 2, 3, 4 occupied 2p's in oxygen. So the electron configuration ends with 2p4. Let's look at another example. All right, in this case, we want to write the electron configuration for bromine. So I look on the periodic table and I find that bromine is down here. So all of the orbitals up to, and in this case, we're in the 1, 2, 3, 4 p's. So everything up to the 4 p's is going to be completely occupied. So I start off with 1s2. That gets me to here. Now I'm here. So the next one is 2s2. The next orbitals come here and they're full. 2p6. Now I'm here. 3s2. Now here. 3p6. I'm now down to 19 and 20. Those are the 4s2. I'm now into the D's. Remember, the D's are going to be one less, so that's 3d10. Finally, I'm to the position of bromine, and so there are 1, 2, 3, 4, 5 p orbitals occupied, so it's going to be 4p5.